Okay. So, today's date is the 2nd of March, 2026. The time now is 12:59 a.m. So, this video is on Riftlang, 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 Riftlang. What is Riftlang? What is Riftlang? So, I'm going to talk about three main things here. Oh, a pen. 1 second, guys. That's the three main things. Let me go to my journal. I want to start with the hardest stuff, the most hardest thing to do. Um, this is three main things. So, I'm going to start with a tripartite interpreter module system. Let me do the address first. So I'm gonna say, so Riftlang.
You need to take a shower, man. Seriously.
I already had a shower, JJ. Stop doing this thing shower. You know my boss.
I'm not. Just talking
No, I had a shower three times. Can't shower every day for you.
You need to take a shower.
No, I'm not taking a shower, JJ. I know story. I had a shower today, man. Go to my shower. You know I like my shower. Don't come in my shower. Don't come in my shower. Don't stink. I don't stink anyway. You have a shower. It's you, man. Not me. I'm not just stop you telling me that nonsense. So, I'm going to talk about tripartite interpreter modules, target bytecode. So, say you have three representation of bytecode. You have a source language. Now, the source language is Java. Let's call it module or Java. And this is source language. Now, this source language has a bytecode. So, Java has a JVM. JVM, the Java Virtual Machine. Java, what JavaScript fucking now? Virtual machine. Machine that gives you a bytecode. Bytecode. Well, because Java is compiled, you have a Java bytecode. Now, the bytecode is can be converted to what we call an AST. It's an intermediate revision of RR because it can always be presented as an AST. AST. Abstract signature. So I'm saying to you that we have first module of the bytecode system. We have a mechanical interpreter. So I'm trying to develop a Riftlang symbolic codec system. So this is Riftlang. So Riftlang is a symbolic embedded language for governance. For governance language. It used to govern files used to govern files. And Riftlang has you go to github.com/Oscar, Nico Bravo, Isaac, Indigo, S River, if Echo, X, Huge Rumble, S Sarah, MK2, MK2. We have Riftlang. So let's define this properly. So we're gonna take three main functions, three types of main functions. You're gonna have the class main, the public string args main, the public string, the public module string, string type, args, main, another main function of the module that Java. And you're gonna have another one called new one func main, fun main, func main in brackets do while do end. And you're gonna have Python def main. So this is three main functions, three entry programs. And then you have to resolve something. There are source. You have one target. You have two sources. You have two binding languages, two interpretation languages. Lua and Python. And you have Lua. Lua is here, and Python is here. So they have different. They speak different dialects. They speak different tongues. They are different languages, as we said. The problem I'm proposing is this is an embedded language system. Riftlang is a governance framework, but it works with the embedded logic of the system. The basic cardinality, the principle of cardinality, and cardinality, which is a shared canonical uniform, 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 normalized, normalized canonical structures. So the uniform local structure is what they say, and this is to have a meaning. So the thing is, so I can't really formalize this now, but I'm trying to do it now. That's what Rift does. So this is the first of the regular. So you go Rift. Rift is the first one, which is pattern matching. But it works with kind of a regular expression pattern matching of the source language that's presented. But the pattern matching of Rift is an ecosystem. So Rift has stages, but so you define what stages are. So I'm trying to move all the stage by parts and 001. Basically, I've ruled the whole system. But then I define what you need and what time you need it. You define yourself. So you didn't have any. So there's no governance files in Rift. You can't govern Rift. Can't govern Rift. And Rift stands for Rift is a flexible translator. So Riftlang stands for Rift is a flexible translator language. It's a governance specification for a better language system. So that's what it is. So that's the first stuff. So the Java target the source and the interpreter language. So if you're using Lua, Python, and Java, you have a bytecode, and the bytecode are interpretable. The bytecode are basically the bytecode are unique to the system, but the AST is interpretable. So the bytecode is unique. The AST is abstract syntax tree is interpretable. That must mean you can can write some kind of code that takes an arbitrary bytecode or some bytecode into an AST. You can run the code as a just-in-time compiler, just in time. So you can have one canonical just-in-time program, which is a little bit of saying you can run on the fly, So just-in-time compile JIT to on-the-fly execution of the target binary. But it's not an on-the-fly system; it's just a JIT compiler that's doing it. So that's why it's on the fly because you compile while you're running the code, line by line, which is just time. So it's based on the bytecode logic, So the problem I'm saying is governance here. The more tools you have, the governance engine has a problem. You have problems eventually. So my solution is what? Symbolic interpreters. So they are not AI, and they are AI. It could be AI, but if they have a proof system, but the proof system is what it what the AI is. All my ASA is symbolic interpreters, but they work on the system. So the reticle rational reasoning framework is what's used to interpret the system. Reticle just means the facts and figures, the data, and the ability to like a chicken and egg dilemma. Is it chicken or egg reasoning and the rational? This is one subroutine that can govern the whole ecosystem. Like you can write the logic in Python for this module, but they have a symbolic interpreter namespace. So they have the namespace solution. This is basically the namespace is basically a registry, and the registry detects the bytecode system, and that's modular. So let me try and clear my board here and clear my board here. So let me clear my board. So I'm not really writing kind of meaningful board, I don't think so. But I just know what I'm writing on the board. I didn't get my data down for my video. It's me like something I here. So it's basically a symbolic interpreter engine. So a symbolic interpreter, if you know what symbol table is in Python, you look up the def keyword in Python, and that will be the same as the public or the public string, the public string args, public main string args, public main string args main, public main string type of string, and the inputs are the arguments here. probabilistic, probably main, and this is main method. So you have a script concern between main method and main. But you have to develop a symbolic codec. Now, the coder and decoder must always have a trident point of yes, no, and maybe. Listen, they must identify the platform based on the language dialect. And the target language must be able to accept the state of the machine. So it doesn't matter whether it's a positive, the valid state, it must accept something to run. So it doesn't say it's just like so. So you're gonna have def main, you're gonna have func main, func main. There are three states, this is three programs, and the beauty of this is the module can be modular. So it's just an interpretation of just like intuition. So it allows you to, but there's no direction. It's just a pole. It doesn't pole. It doesn't pole. It's waits for kind of a sort of stream of bytes. So it has like a way of waiting for people. Because instead of waiting for people, you wait for something that's meaningful. Something so instead of waiting so the thing about waiting like a sleep of 60 seconds. This can be timed out. This can be some can come in 61 seconds, 61 seconds. And this 1 second is based on the moon. That's what they skip. That's what happens. So this is waiting. I don't do sleep. I just do. This is for a time. Probably time on the sleep in Python or so. I wait. I probe. You can either so you don't sleep for anything. So if you sleep for 60 seconds and you wait for 1 second, you have lost information. You cannot go to the next phase. And this information takes the time to prove. It doesn't matter what the proving is, but it's part of the job of sending information. This is a string of bytes, and string of bytes is a duplex. So you have a duplex string, and you have a triplex string. What I call a trident. Basically, you're gonna have a trident relay string. So instead of relaying observer, information, you have a replay. So you see the relay. So you're gonna have a system operating. So the goal is to have an embedded system that reflects the if you go to GitHub.com, flush will be next O for Oscar, B for Bravo, I for Eagle, N for Rule, E for Echo, actually, E for Umbrella, etc. Reflag, alpha. So you can try and vision, but there's a codec, there's some sort of encoding system that's shared. You know what I mean? There's some codec system that's shared between the three states. So this is a three pole, so three polar, you have to choose a trident polar interpretation. It can mean something. So wait for a signal. So when you have a trident interpretation of a system that's consensual already, you have a trident interpretation. You have trident, trident. You have trident. And when you trident, there's no interpretation. So you don't have a duplex string. So you can have a duplex string. You can have a one-way string, which is called a reader string. But you have a reader is a English reader. You can have the system have a translation. The translation is the interpretation. So you wait for some of to get to the time. It goes to have Riffland govern three models at the time. Three binary, two binary two drivers. So you have the also only problem I'm saying is that you have different between extension and plugin. Extension can be a module, like a binding module. It's like a binding driver. So extensions are bindings. Extensions are bindings. Extensions are bindings. Drivers execution logic. Drivers are execute, and plugins execute. Plugins are hardware. They execute. So extensions don't execute. All bindings and extensions are squares. You can hold execution logic, but all rectangles are execution logic. So the all rectangles are squares. This is a binder and driver. So the shape of the space is like an unflat picture. So I can't never write a J before, so I've used the air to write that. So good to have the system have previous notation of the computation form. So the bytecode is mechanical. So it doesn't matter what the module is, it's loaded up in the system that is intended to do via the Trident ruling system, which we try to run some Trident interpretation system because it allows interpretation of system. And how this works again is this. So let me clear this board and write one more thing. Let me show you some new kind of feature of working in Riffline. So normally this is very important to get right. So you have the macro in Rust, the Rust macro, exclamation mark, print, line, in brackets, hello, now, hello Namji, in source, in target, hello Namji in Python, in target. So target is the macro. This is a Rust macro. So the target, the target is the target. Hello Nandi in target. The target is the Python, and Lua. But these are just the vice code implementation of Python. You have the this model, DISAM model in Lua, and you have the in Python. You have the Cython. So you have C Cython. Cython this is assembler. This and you have this the Python Cython this you have S5 bridge. You have the Lua SI bridge, CSFI, Lua SFI bridge in C. So you can have, but Lua is really embedded language, so you can use this in C, but Lua is really embedded language, so you can use Lua, you can really embed Lua, different from code from Lua and the terminal, so and the source function. You can have Lua SFI in there. So, the goal is basically to have a system that handles a foreign function interface for you as kind of a codec. So the first solution is the codec. So the first, so you have a shared between Python and Lua. That's one codec format, and the codec format already knows how to resolve into the system. So when this macro prints, it will be a system. But you have one problem here. You cannot do this properly. The problem I'm saying is this explanation mark is the term markup. This macro just wants one to Rust. But let's just say this type of language is Riffline. So this is Riffline is solution. So exclamation mark is a token, but this tokenizer is a sparse token. It's a sparse token. So be very careful. This is needs to run. It's sparse token. So the sparse means you will run on Python and Lua. Python and Lua. But this is basically if you go to Java, this is Java as well. So if you say this is Java, this is a compiler. So I'm giving you a compile language, Java or Rust, to interpret language. To interpret language. Just when you choose this token, this is macro. This token is a macro definition. And this macro expands, because macro expands, they expand to two interpretation of system. Very important to understand that did, or everyone is watching. The macro is just not a simple token. It's a simple token. This is if it's in this language, if it's in this context, you switch to context. If it's in this iOS system, if it's this target platform, like x86 underscore 64 underscore ARM7 underscore MSVC, Microsoft or ARM or IKE. Then what's the platform? You have this token here. This is so it's sort of print line column. Print line is a macro. So it's an invoking structure. You can just have this removed, and this will not run in the program. So you can have a question mark before the very one. So the question mark are two tokens. So the question mark and the exclamation mark are two tokens that work together. So the question mark says this is a probe. This is a probe. So you have question mark colon print line hello world target language. Now the target is basically the identified platform and the total of programming languages, but for the target infrastructure. So you have an answer. This is really a system. So the question mark is what's a radical reason rationale, and the question is just this question mark means literally I'm gonna probe the system to see what is something there. So it's gonna be like is there a guide in there? Can you see the driver there? But the question mark is basically a probe system. It's like asking a question, if this becomes ambiguous, like you have three states. You have three channels. 1 second. You have three channels. You have two channels. The two channels. Hello, Nate. You're good. you have three channels. You have three channels. The three channels are literally yes, no, maybe. You have three channels. So the three channels are yes, no, maybe. So you have channel one, which is the primary channel. So every channel has channel. So you have interpreter. So you have three channels. You have channel one. So channel one is I'm trying to do this properly. I can't remember because I'm going to read something. So channel one. So channel zero is a reader channel, a reader first channel. Reader first. So channel one is basically a reader channel. So HTML bytes is channel one or a reader stream. So it reads artifacts that's coming in, but it can write as well too. But it's because you can write something. The more you just read something, you have to read. There's a polarity of double read, half a write. So every double read it does just half a write. That could be writing to some kind of module. And channel one will be double writes. So we have so you have double writes. So you're gonna have so basically you have double read. So you're gonna have 4R, two writes, then 4R, 4 reads. And channel two we have four. Channel one will have 4 writes and 2 reads, and vice versa. And vice versa. So you're going to have this channel. But this is not. This is just the manual. This is a duplex string. So this is a bipartite duplex string model. So you're gonna have the last one, which is written. So the reason is a probe. So you have the probe. So you're gonna have I'm busy.
I'm too.
Let me finish.
I'm busy too. Because they got their shoes.
Let me
They
finish.
got outside those shoes.
Let me finish, man.
Finish. I'm doing something up there. And you know.
But I need to finish.
Shut up. So nice. You your fucking dog now. You know the dog I'm being for. Fucking idiot. Get out of here.
Okay.
Get out of here.
I'm going.
That's right. I get a message, man. Little smooth fight. Little smooth fight.
Don't worry. He's just doing his thing, yeah? Chris?
He's making more noise than anybody else.
Right,
And he knows I'm on air. I'm saying, peace. Can't get you on workload, yeah? Can't get you on money for fucking streaming Naira. Understand that, boy? You're not working for that for me.
So I have to go now. So I have to go now. So I'm going to my room. Don't worry about me.
You know any relevant place I can do that.
No, I'm going.
He's dropping in drop.
So
Chris, we've all got to share
I know that, but you didn't know what he was doing.
I'm going to my room now. Let me just happen.
He's quiet.
But you're gonna have a good stream.